The last thing I want to talk about regarding hyperbolas would be their reflection properties and some applications based off of those reflective properties. So let's start with the first image on the upper left. The reflection property that we get with a hyperbola is such that if we have some sort of a hyperbolic curve or surface, and we have light that is emitted from one of the foci, and it goes and then it hits the hyperbolic shape and gets reflected, it'll get reflected outward as though it was from the other focus. And the same thing happens in reverse. If we have any light that's moving in directly towards this one focus, it will get reflected off of that hyperbola, that branch of the hyperbola, and it will be reflected directly into the other focus. So one example that uses this would be certain types of telescopes. So there are all sorts of different types of telescopes, so this certainly isn't all of them, but there's one type of telescope that has two mirrors. The main mirror is parabolic in shape, and then the smaller mirror is hyperbolic in shape. So what happens with the parabolic mirror, we know that if anything is headed directly in towards that parabolic surface, perpendicular to the directrix, if anything is headed directly in there, it's going to get reflected so that it heads directly to the focus of that parabola. But if we have a hyperbolic mirror that is built such that its focus is the same as the focus of the parabola, what happens is that all of these bits of light that are reflected off of the parabola towards the parabola's focus are also heading directly towards the hyperbola's focus, and what that means is that it will get reflected off so that it hits the other focus, which is where we would put our eye when we're looking at the telescope. So by using a parabolic and a hyperbolic mirror, two different mirrors, we end up getting all of these bits of light, which is what we would see, they get reflected and they go straight into our eye. So what we see when we look at this little mirror, instead of looking out and seeing all sorts of things, we're looking directly in one direction, and so we're getting a small bit of what's happening in the sky far, far away. It's a little bit simplistic. There's more that goes on with that, but the important thing to know is that hyperbolic mirrors are often important in telescopes. So the other thing that I want to talk about is how hyperbolas can be used to locate things. Our textbook has an example of how hyperbolas can be used to locate a ship if there are different radar kind of satellites set up. We know that a hyperbola is the set of points such that the distances of the difference of the distances between that point and the two foci is a constant. So what happens is a ship can communicate with these two satellite dishes or these two radar stations, whatever you want to call them, and can send a signal there and back and can figure out the difference in the amount of time that it takes for the signal to hit both of those. And the difference in the amount of time can then be converted to a difference in distance, so we can know the difference between the distances between the ship and the two stations, and that tells us a hyperbola that we know that the ship has to be located on. Now we know that hyperbolas have two branches, but based on which one sends the signal back more quickly, we can narrow it down to being on that branch. So with these two stations and communications, this ship can tell that it's on this branch of this hyperbola, and then if it also communicates with the two stations over here, that gives us another hyperbola, and we can see where the hyperbolas intersect, and that tells us exactly where the ship is. Now, of course, nowadays we have GPS on ships and all sorts of other ways of identifying exactly where the ship is. So there's another use for this, and this is actually something that has been done in Antarctica, in the Southern Ocean off the coast of Antarctica, also in the Indian Ocean. I've actually gone in to the online library and looked at academic journals that were written about how hyperbolas can be used to find the locations of whales, including blue whales, humpback whales, and other species. So let's say that we are doing a project in Antarctica, and this image is from Google Maps. It's part of the Ross Sea, which is near McMurdo Station, which is the largest research station in Antarctica. It's an American research station. And so let's suppose that they want to figure out where the blue whales are in this region. Now, you can, of course, send a ship out looking for whales, and you might get lucky and find a whale, but we're looking at distances that are hundreds of kilometers. And so really, if you're going off in some sort of a path and you're trying to find the whales, you might get lucky and see them, you might not. It's really a haphazard sort of a thing. It depends on a lot of luck, and even then we're not getting a whole image of what's going on. But what they can do is they can send 3 ships out to different locations and equip each of them with a microphone that gets lowered into the water to listen for the sounds that whales make. Now, blue whales, their calls can be heard hundreds of kilometers away. I think I looked online and it was 800 kilometers or 500 miles away. So what they can do is they can record at these 3 different locations the audio that includes the sounds that the whales are making. Now, each blue whale has a unique call, so each one is different from the others. And so what they can do is they can use GPS to figure out the location of the boats. They can synchronize the recordings, and when they compare the recordings, they can look at individual calls that match up from the different recordings, and they can see what the difference is in the times. And just like in this example above with the ship, knowing the difference in the times that these microphones recorded the calls, that can tell us the difference in the distances between the particular whale and those 2 microphones. And so what that does is it gives us a hyperbola, and we know that the whale is somewhere along that hyperbola. Now again, we know that hyperbolas have 2 branches, but we know which branch it's going to be based on which of the microphones got the whale's call first. So then the reason we need a 3rd ship is because when we have a 3rd ship, we can then compare these 2 recordings. We can find the differences of the times and then calculate the differences of the distances based on how quickly the whale calls move throughout the water. And then that gives us another hyperbola that we know is, it's a path that contains the whale, and we can look to see the intersection of these hyperbolas, and that will tell us the exact location of the whale. And so this is something that has been done in the Southern Ocean off the coast of Antarctica. It's been done in the Indian Ocean. Those are just 2 examples that I found research papers written on online. But I'm sure there are other places where this has been used, and it might be that there are 30 or 50 or hundreds of blue whales in this portion of the ocean. And by recording the different calls and going through this process and separating out the calls, because remember, each whale's call is unique, they can figure out the general location and the number of all of the whales that have sounded during that time, which is really fascinating. I spent a month on a ship that was going on an expedition to this part of Antarctica, and there's so much that I learned about how mathematics is used in navigation and in different areas of research. And it's really fascinating that even today, this sort of research uses hyperbolas to figure out what's going on underneath the sea. And at this point, one other just interesting thing that I've heard, we know more about what happens in outer space than we know about what goes on in the depths of our oceans. So these are some of the most unexplored parts of our planet, and to know that the shapes that we're learning about now are used in researching the unknown about these places, I find it really interesting, and I hope that you also find it interesting as well.